Morning, everybody. Welcome to another V lecture in the CCIE Collaboration Lab series. We're going to be looking at Cube today. Just looking at the basic setup of Cube. Once again, thanks for joining. There's been a little scheduling change in how these are working. It's still going to be every Wednesday where these are going to be kicking off, but we're going to be running them at 12 noon Eastern time, or 11 a.m. Central, which is where I am. So anyway. We'll talk about Cube today. We'll try to get off the ground on some of the topics in Cube and just get the basic Cube functionality running. I do have a nice little PowerPoint for us to watch today. It's really quick, so we won't do anything crazy there. But anyway, we'll get right into it with the Cube Basic Setup lecture. So we're going to be talking about a few things today. First of all, we'll give an overview of Cube and what it does and why we're going to use it in the lab. Of course, it's on the blueprint, so that's one of the major reasons. The next thing, we'll talk about deployment modes and how you might use Cube or how you might be asked to use Cube in your lab. Also, we'll talk about the SIP bind command and the different ways that can be applied. We'll also talk about SIP profiles and how powerful those can be in terms of changing things in the actual SIP messaging, and that'll be something that's very useful to you in the lab as well. And also, we'll talk about dial peers, and basically, don't let Cube scare you. It's just essentially a iOS routing device. I mean, you're used to using dial peers on, maybe CME, getting your PSTN going. It's the same thing. Cube is going to have dial peers that manage its dial plan, and that's the exact way that we're going to configure Cube. So, getting into, first of all, the overview of what it is. First of all, what does it stand for? It's the Cisco Unified Border Element, and that doesn't really tell you much about it except that it is a border device, meaning that it's going to be on the edge of your network somewhere, interfacing with a PSTN provider or something like that. It doesn't have to be a PSTN provider. It could be, at the central point of your network, essentially, creating kind of a centralized directory structure. So let me just go ahead and pull up a drawing pad so I can illustrate my point here. So if we had our nice circle here, which is Cube in the middle, and let's say that we had a call manager device over here, and another call manager device over here, let's call it HQ and Site B. These devices, these communications manager servers, are going to be connected to Cube in some fashion. This can also be, or this can be an H.223 trunk, for example. This could be a SIP trunk, for example, or vice versa. It doesn't really matter. So those are the options that we have when connecting to Cube. Then Cube is going to just accept those connections from each of these two devices via a dial peer, and then it's going to route from device to device using the dial peer methodology. So this is basically all there is to it. There's nothing crazy about this. It's just two clusters being connected together through Cube. Now you can get crazy with it. You can throw other things in there, like you can go to the PSTN, for example. Maybe your PSTN connection is a SIP connection out to a SIP provider somewhere, and your Cube is actually going to foster that communication. So it's going to say, hey, I'm going to connect to the PSTN provider in some fashion, and the HQ cluster, for example, is going to connect to that PSTN provider by way of the Cube. And the Cube acts as a border between the two networks there. So basically, if I draw, to illustrate the point, if I draw just a nice little red line across this direction here, this is the point of demarcation in your network here. So for example, we have this PSTN connection going from Cube to the PSTN, and then we have this HQ to Cube connection. These are completely independent of each other. Cube is going to handle that communication completely. So let's say that HQ connects to 10.10.1.1, which is the IP address of the Cube loopback 0. So let's say that HQ says, you know what, I'm going to connect to that loopback address. That's the IP that we've configured for that. Well, maybe the PSTN is going to interface with a public IP address. So let's say that the Cube IP address is just, 8.8.8.8, which it's not. That's the Google DNS server. But let's just say that that's our Cube public address. The PSTN, obviously at this point, has no idea about this address, let alone the address that's on an endpoint out here, which could be, you know, 10.10.11.100, let's say. So that would be the IP address of the phone. So 10.10.11.100 is going to communicate with 10.10.11, which is the loopback address of the Cube router, and then Cube would communicate using its IP address over here to the PSTN. So in that way, it acts as a border between the two networks. So it's kind of almost a protecting device if you want to look at it that way. But it's a point of demarcation of the network, which means that you're going to have signals that are regenerated by the Cube and sent out as a fresh, brand new signal. So, and we'll talk about that a little bit later. But I just wanted to give a quick little overview on that. So, what did we talk about just then? We basically covered everything in this slide. It terminates and originates signals and media streams. Of course, we can go from H.323 to H.323, SIP to SIP, H.323 to SIP, SIP to H.323. So if you guys are familiar with the command that you might put in an iOS device for routing, you know, this looks very similar to this command, this allow connections command. So you have a voice service VoIP, which is your global configuration on the router. And then you're going to have a command section that tells you to allow these type of communications between H.323 and H.323, SIP and H.323. So you have to physically allow that in the router. You have to go ahead and configure that. So the next thing it's going to do for you is signal interworking. We talked about that a little bit. If we go back to the drawing here, we talked about H.323 and SIP being supported. Well, we have H.323 here, and maybe this is a SIP trunk over here. Cube doesn't really care. It's going to take each of those signals in and terminate them and then regenerate that signal to the other device. So not a problem. Cube can take care of that. So that's signal interworking there. Media interworking with DTMF, fax, modem, codec transcoding. Basically DTMF, if your DTMF methods are mismatched, then Cube can resolve that. It can be configured to resolve that. Also, it can perform transcoding for you if you have a codec mismatch. So for some reason, let's say that you have your H.323 trunk on this side set to use G711 only, and then on this side you have your SIP trunk set to use G729. Well, obviously at that point you're going to have a codec mismatch. So at that point you can invoke a transcoder directly on Cube, and at that point it's going to resolve that codec mismatch for you. So and you used to have to actually register that to the Call Manager Express on Cube. So you have to configure a quick little instance of Call Manager Express, register that transcoder to it, but now you can register it directly to Cube itself. So moving on here to the next item here, the address and port translations. Obviously, if this is going to act as a border element, it's going to have to translate between addresses and different ports. So that just is kind of what we've been talking about already. It's going to act as the border, and it's going to act as the demarcation point. You have one address and one port, one address and one port over here, and you're good to go. So any questions so far? And the question here, basically it is a IP to IP gateway. So that's all it is really doing for us. I mean, it can also be configured. You can have a ISD and PRI on it if you like, you know, but it's really not used in that method often. It would be mostly used for SIP to H.323, SIP to SIP, those kind of things, IP to IP gateway. Question here, is the Cube a security risk in any way based on its default configuration? So it can be a security risk in some ways. There is a command that's actually on by default now in iOS 15.1. I don't remember exactly which. I think it's 15.0 where it turns it on. But it's basically this command, IP address trust authenticate, and what that is going to do is it's on. Like I said, it's on by default, and many of you have already experienced this in your networks. When you upgrade to 15, everything breaks for some reason. You don't know why. Well, that's the security mechanism kicking in, and what that does is actually takes your dial peers and takes all these session targets, meaning where it's pointing to, the IP address it's pointing to on the dial peer, and it's going to add those to a trusted list, meaning that those are the only trusted devices that are allowed to communicate. Well, if you don't have dial peers, or if it's not used in that way, then you have things that break. So generally what I recommend doing for especially for the CCIE Collaboration Lab is to turn that command off with the no IP address trusted authenticate. So that's a security topic there. I don't know if that answered the question. I guess it's not necessarily a security risk. You can firewall it just like you would any other device. But the security mechanism that I recommend turning off for the lab would be that no IP address trusted authenticate. So, hope that makes sense there. All right. All right, so cube deployment modes. So we'll talk about the different deployment modes that we have available to us. First of all, there's media flow through, and just logically speaking, let's think about what that could possibly mean. Media flow through. Well, this is one of those things where what you see is what you get. Cisco has said media flow through, that means the media flows through the cube. So there's really not much to it than that. I mean, and just if you needed an illustration, let me change colors here because this is getting a little messy. If you have, one endpoint over here, like I'd already said, 10, 10, 11, 100, another endpoint over here connected to cluster B, or site B, you're going to have that media that would normally flow from phone to phone, just like that. Your signaling obviously would have to be set up by the signaling path, meaning HQ, cube, SB. They would have to actually set up your signaling portion of that, but your media would flow from endpoint to endpoint. Well, now in cube, you can go through and say media flow through, meaning media flows through the cube itself. And there may be situations where that's not so great, because you might have this HQ cluster, which is in San Jose, and this site B cluster, which is in Chicago, and maybe your cube is in Florida or something. Now think about how your media has got to travel. Your media is going to go from San Jose to Florida to Chicago. So it's kind of taken a roundabout path to get to the actual phone itself. The signaling it's okay to do that. We might have to use mechanisms such as early offer or H323 fast start to overcome some of the signaling delay there. But with the media stream, at that point, you're basically forking it through a different area that it really needs to go. But that is media flow through. That's what we're talking about. So the media flows through the cube in that case. So by the way, that's on by default. So that's the default mechanism for cube, media flow through. All right, so the next thing we have here is media flow around, and that's basically your default behavior of a phone normally if it's not going through cube. Your media is going to flow around whatever the signaling path is. So cube is setting up your signaling path, and now we're saying media flow around, so that means let the endpoints actually communicate together, and don't dictate where the media flows at all. Just set up the signaling path and get out of the way, is basically all that's saying. So only the signaling is terminated at cube at that point. Media flows between endpoints, and it is recommended for enterprise networks, of course, because you are within this secure bubble in this enterprise network, right? And you're able to communicate with this device or this device in the most efficient way possible in terms of routing, how the routing's set up. Your routing protocol determines that path XYZ is the most efficient way to get there. So it's going to take XYZ, of course, rather than having to go through an intermediary device to take care of that media flow. So, and the media anti-trombone is the other thing too, and this is kind of interesting, and I think I'm going to have to get a new drawing for this one here, folks. So the media anti-trombone here, let's say that this again is cube in the middle, and we have a PSTN cloud, just a gorgeous cloud there, and we have, well, we'll just say one communications manager, so the HQ cluster. That's connected to cube, let's say via SIP, doesn't really matter for the illustration purposes. So we have a phone that's over here connected to HQ. We also have a PSTN phone over here, or it doesn't have to be a PSTN phone, it could be another network somewhere, but just for this example we'll say PSTN. So we have a call that goes out to cube that says I want to hit this phone over here, whatever extension that is. So cube says I know exactly where that's at, that's on the PSTN. Great. Well, now this phone itself has a forwarding rule, and I've kind of, let me get out of the way here, folks, sorry. It has a forwarding rule set up to go back into the cloud and come back through cube back to this phone or another phone on the network, let's say. Let's say it's forwarding to this phone over here. So at that point, what that means is that you're basically coming back in the network. You know, you're taking that call, Cube is sending it out, and it's coming right back in. So what that's doing is kind of looks like a trombone, right? You're kind of going like this, coming back in the network. So that's why they call it a trombone. Now, if you say anti-trombone, Cube is actually going to be smart enough to say, hey, wait a minute, this call is forwarding back in, and kind of take note of that. And rather than having to set up the signaling path all the way through this area, it's going to cut it off right here at this point here, and just keep it within the network itself, rather than having to go out and use another resource of the network. So that's the anti-trombone mechanism there. All right. No questions on that? Looks like we're good. Okay. Obviously, feel free to ask questions at any time, guys. So, all right. So now the SIP bind command. Now we're getting into some very important stuff here. The SIP bind command is going to be where your process is running on the cube itself. It's going to pick an interface for this process to run. Now, the SIP bind command is useful in other things. For example, CME, voice register global, configuration on CME for SIP phones. But also in Cube, it's going to say where your SIP packets are going to be accepted. So if your SIP packets are going to be accepted on the loopback interface, then you're going to have to bind your traffic for SIP or H.223, whatever you're accepting, to the loopback address. So in the example of SIP, because SIP is what you're going to be using most often, if you have a choice ever in the lab, use SIP, please. Just save yourself some headache. Because H.223 to SIP can cause some issues, of course. There are ways to resolve that in Cube, but why have to worry about that in the lab if you don't have to? So keep it SIP to SIP if you can. Anyway, so it attaches itself to the SIP process to a specific interface, and you can do that a couple different ways. You can do that with the global bind command, which is under voice service VoIP. And you can see that down below here. The voice service VoIP SIP. So voice service VoIP is your global voice service configuration. And then under that, we've said we want to configure SIP. And then from there, we say we want to bind our control or media or both or bind all. Bind control to the source interface of Fast Ethernet 00 in this case. So we want to use Fast Ethernet 00's IP address as the one that's going to be connected to for the SIP process. We also can use multiple different bind interfaces. So for example, if you did want to use a cube to act as a demarcation between your network and the PSTN network, maybe you want to use different bind commands for that. So now you can do that at the dial peer level itself. So if you wanted to go from the HQ cluster to the cube on the internal network, you can have that bound to a specific dial peer, incoming and outgoing. We'll talk about that. And also, if you wanted to go to the PSTN, you could have that specifically bound to another interface on the router. So it doesn't have to be the same interface for everything. Globally, of course, you have no choice. That's the same interface. You can also, you can apply a global command, but then you can also get more specific and apply a dial peer command. And of course, the dial peer command at that point will take precedence over the global command. So otherwise, it's going to choose the best interface available, meaning the best routed interface. So whatever the path is most optimal, or wherever the path is most optimal, it's going to choose that interface to go out. And that's not always necessarily the best thing to do, because there may be different interfaces that it chooses to go out based on how the routing mechanism has changed, or the routing updates have changed, or whatever. So we want to always try to make that the predictable interface, so that way the devices that are trying to communicate with it don't end up having a 404 error because they can't find the other device. So, okay, so now we've got our bind control or bind commands figured out. This bind control, bind media, of course, is going to bind each of those different processes, whether the control or the media, to the interface itself. So that's how that's going to work for us. And here you can see the configuration commands. Voice service VoIP, global voice service configuration, SIP, and then we're binding our control, in this case, to the source interface of Fast Ethernet 00. And then there's the dial peer example. It's kind of a mouthful, voice-class, SIP, bind, control, source interface, Fast Ethernet 00. So there's a lot to that, of course, but feel free to question mark it because it makes it a lot easier. So bind command, very important for connecting your devices together in the network. Any questions so far? Are we looking good? Okay. All right, so moving on now to SIP profiles. SIP profiles are super powerful. You may end up having to use them in the lab to resolve differences in codec or DTMF relay type, or maybe just to do something trivial like change the name of a caller ID or something like that. I personally have a lab like that somewhere buried in IP expert stuff. But anyway, so it allows you to customize SIP messaging. That's the whole point of a SIP profile. And why it's so powerful is that you can put this device, the cube, in the middle of the media path or signaling path and say, whatever I got in from this person or this device, not person, whatever I got in from this device, I'm going to change in this method. So it's going to search for a string and replace that string is all it really comes down to. So just like a voice translation rule, you'd be searching for a dialed string and you're going to replace that with another dialed string somewhere. So with Cube, you're basically going to be able to do this on a global level or a dial peer level. So it's going to allow you to do it very specifically to a certain endpoint, or maybe if you don't want to get specific with it, make it general for every endpoint. So keep in mind also that when you look at the actual SIP messaging coming from one endpoint to another, you're going to see the communication come in from that SIP endpoint, and then after the SIP profile is applied, then you'll see the information go out as you've configured it. So for example, if we've got another drawing here, if we have one device over here, HQ cluster again, to the egg-shaped cube, and to site B, and another phone over here. So the SIP profile, let's say that I wanted to change the calling name. I actually have this in the demo, so this is perfect. HQ phone 2. Let's say that the calling name is HQ phone 2. And I want to change that calling name to be SIP profile, just to illustrate the purpose of the SIP profile, HQP2. So Cube is going to actually change that for us. And then as it's received on this phone over here, the display will display this name here, SIP profile HQP2. So that's something we can do in a SIP profile on Cube. So as it's received here, we're going to receive the name as HQ phone 2. It's not going to change what was received. It can't change that. It can't modify anything that it's already gotten. So it's got to take in something from Cube. So at one point you're going to look at the debug and scratch your head like, man, why didn't it change this? This doesn't make any sense. Well, it's because it received that and it can't change what it received. So it's going to take what it received then, which is going to be a SIP invite. We'll talk about that messaging in a little bit because that's very important as well. But it's going to receive an invite to Cube, and then it's going to say, okay, I've got this string here that says HQ phone 2. I'd really love to change that to SIP profile HQP2. So depending on where that's been applied, whether the dial peer level or global level, it'll change that as it goes out to site B. So we would go through a series of configuration commands to look at that and apply the SIP profile accordingly. Now those configuration commands look like this. So we have, this one's actually changing the video bandwidth info here, but this is voice class SIP profiles 20, so that's just an arbitrary number that was chosen for the SIP profile number. We've also got the request invite, and we're changing the SDP header. And everybody remember what the SDP header is, right? That is going to control your media negotiation, control your capabilities between SIP endpoints. So that's how it's going to control that. With H323 would be H245 negotiation would be your media. Now with SIP, it's going to be SDP headers that's going to control that. So that we're modifying here the invite, the actual invite message that goes out. We're saying the SDP header in the invite, the video bandwidth info field, we're going to add information. We're going to say B equals AS colon 4000. So we're modifying the bandwidth for that specific SDP header that goes out, depending on where you apply it. So you can apply that globally with the voice service VoIP command, SIP-profiles 20, of course referring to the voice class SIP profiles 20. Also, the dial peer voice 20 VoIP, like this would be a dial peer level command for us. And then you can apply that under there with the voice-class command. So voice-class SIP profiles. All right, so any questions so far? Looks like we're looking good again. All right, now there's a couple other things I want to talk about, of course, but this is a great reference material for Cube. So if I pull this up real quick, I recommend going through this and really understanding this this document really well, because this will explain everything that I just kind of went through. But there are other things, of course, that we're going to talk about later that may not necessarily be in here. But dial peer matching, we haven't talked about dial peers yet, but if you're not familiar with that, definitely get into dial peer matching and check it out, because that's going to be a very fundamental process of how Cube is going to route the call. Talked about SIP profiles, media path, that kind of stuff. So definitely check this out. I'm not going to go through the document right now, but I wanted to actually reference it so at least you knew that it was out there. So, okay. So let's get into some demo mode stuff. That way you can stop falling asleep on me and all that kind of stuff. So we're going to use, in this case, we're going to use R1 as our Cube device. So R1 will be the Cube between the different clusters that we have, and I happen to have 3 set up, which is going to be HQ, SB, and also the Call Manager Express device, which is going to be the R3 router. So R1, the first thing we're going to do on Cube is, let's say you get in your lab and you say, oh, there's a Cube here. What's the first thing I need to do if there's a Cube? Well, I've done the command for you here, but I'll do show run section voice service to show you. Mode border element. The command needs to be entered for your Cube to function properly. So the bummer about this mode border element command is that once you enter it, it's going to ask you to reboot. So that's one of the reasons why I've already entered it here for us, so I don't have to wait on a reboot. But mode border element under voice service VoIP is something that should be entered to make sure that your router functions as a Cube. So mode border element enabled right there. Also, what I mentioned earlier, thanks for the question by the way on that, the no IP address trusted authenticate. So this is going to turn off that authentication for different devices coming into the router. So if there's a device that's not recognized, it would drop the communication, and you wouldn't know why. So I recommend just turning that off by default. It's going to save you a lot of time and energy. Also, we talked about these commands: allow connections H323 to H323, H to SIP, SIP to H, H to H, or SIP to SIP at the end. So that's one of those commands also that you should probably just pop in the router by default, because why deny something unless they're specifically asking you to deny something? Why deny something in the lab if you don't have to? So I recommend just putting those in right off the bat if you have the opportunity to do so. Then obviously they may ask you to say, hey, make sure that you don't allow H323 to H323 connections. Well, at that point you're going to need to remove that command from there because that's what they're asking. So anyway, moving on here. The SIP configuration under voice service VoIP is your next thing. And notice we have a global bind command done for control and media using the source interface of loopback 0. So if I look at the loopback 0 interface, that happens to be 10.10.1.1. So now we've said that we're binding our SIP process to this loopback 0 interface for both control and media traffic, by the way. So we've said that that is going to be where a SIP process is running. So we can also define that on a dial peer level still. We can override that loopback binding with a specific dial peer if we'd like to do that. We don't have to do that though. Now every dial peer you create is going to be bound with this source address of the loopback 0. Now, a couple of other commands. See, I have a SIP profile assigned here, and we'll look at what that SIP profile does. But this command that I did not mention in the PowerPoint presentation, this pass-through content SDP, very important for video communication through the Cube. Now, why is that, you ask? Well, this might be the perfect time to talk about SIP signaling. So let's examine what happens in a SIP signal or a SIP communication between two endpoints. So let's say you have endpoint 1, endpoint 2. And you know what? We'll throw in the Cube, obviously, because we're talking about the Cube. So the first thing that's going to be sent out, let's say that endpoint 1 is calling endpoint 2. What is the first thing that we're going to send out? An invite, right. We're going to be sending out an invite to Cube, right? Because we're flowing through Cube at this point. We've got our signaling set up to point towards the IP address of Cube. So we're sending out an invite. Now, next, what are we going to do? Or what's Cube going to do? Cube's actually going to take that invite and say, oh, thanks for the invite. I see that this is pointing towards endpoint 2. So I need to send this invite to endpoint 2. So Cube then is going to regenerate that signal and say invite to endpoint 2. So now endpoint 2 knows about it. So in the meantime, while it sent that invite out, it's also sent back to endpoint 1 a message saying that, hey, I'm working on this, right? Trying, 100 trying. I'm trying to get this information for you. I'm trying to ring that other side, and so forth. So it's a nice message, I guess. It's an informational message, is what it really is. Informational and provisional message, but it's a nice message if you really want to look at it that way, so you can remember it. It's saying, hey, I'm working on it, and so if you wanted to be even nicer, if you wanted this guy, for example, to be even nicer, you could turn on prac, which is a proactive acknowledgement, meaning that it has to respond to anything with a 1XX. So anything starting with a 1, it would need to respond to. So if you're saying 100 trying, this has got to respond, or endpoint 1 has got to respond with an ACK in that case. So it says, okay, so that's even more polite, but don't need to enable that. We don't need to enable that for the Cube communication. So sorry, I didn't mean to confuse you guys there. Hopefully that didn't. But moral of the story, we're sending out an invite to Cube. Cube is then sending out that invite to endpoint 2. Meanwhile, Cube says 100 trying back to the original endpoint that called. And now once endpoint 2 receives this, it's going to actually receive a 100 trying back, Cube is, from endpoint 2. So that's great. So now we know that endpoint 2 is attempting to communicate with Cube in some way. So that's great. So now the next thing that's going to happen is either we're going to have some type of error or we're going to have ringing, which means that the phone is actually ringing. The endpoint 2 has located the actual phone itself it wants to ring, and it's ringing it. So at that point, we will get a message back from endpoint 2 saying 180, ringing. And by the way, these messages here, trying and ringing, they don't have to be that. They're really all they're looking for is the number itself here. So 180 or 100. Communications manager just puts in trying and ringing. So that's what we'll always see, but it doesn't have to be that. If it's not 100 trying, it could be 100 Andy is cool, but no one would ever put that in there unless they really wanted to. But so 100 trying, 180 ringing comes back. Cube receives this 180 ringing, and now it says, it's ringing. I need to forward that on to the endpoint 1 in this case. So 180 ringing is going to be forwarded there. So now 1 is actually going to get ringback tone. It's going to say, oh, it's ringing at that point. Great. So the next thing that happens is obviously we're ringing phone 2. Phone 1's already sitting there waiting for somebody to answer on phone 2. Now when phone 2 answers, then that's where we get the actual media negotiation in delayed offer, meaning that the SDP or the media negotiation happens at the point where the person picks up the phone rather than the point where the person sends the information to ring the phone. So basically, if I pick up the phone here on endpoint 2 in delayed offer, which is what this is, I'm going to now send a 200 OK. And that 200 OK is going to contain an SDP. An SDP is Session Description Protocol, and that's going to describe the media capabilities of the endpoint. So when it picks up the phone, it says, I have these media capabilities to use to speak to you with. And it's going to say, I have G711, G729, ILBC, whatever other codec that it has. It may only have one codec, so it'll send only one codec to negotiate with. But it's going to send its capabilities to Cube. Cube then is going to say, I've got capabilities coming in. I've then got to regenerate that and forward it out to endpoint 1. So then endpoint 1 gets those capabilities and says, I see that you have the ability to run G711, G729, but I would actually just want to run G729. So they negotiate at that point G729, and it sends an ACK back to Cube. Cube will then regenerate that ACK to endpoint 2. And then that is your SIP communication. That's all your delayed offer communication. I should specify that. Delayed offer. And it sounds bad, but that is, that's just the way they describe it. Delayed sounds like, I don't want things to be delayed. Well, it's just the way that they describe it. The offer is actually coming, the offer, meaning the SDP, is actually coming from endpoint 2 when it picks up the phone. So that's why it's delayed. Now, in early offer, you can have the SDP, which comes out first here at the 200 OK. You can actually have that come in the invite from the original phone. So that way it says, hey, look, I want to call you and I want to use G729. It puts an SDP in the original invite. So that way, when the phone responds with a 180 ringing, or a 200 OK, that is, when it actually picks up the phone, it says, okay, I'm okay with those codecs. And at that point, the media is set up without having to wait for that ACK coming back from the original phone 1. So, delayed offer versus early offer there. But what we're really interested here in is the SDP. So when we send this SDP information, that's going to contain obviously codecs. So audio codecs like G711, G729, but also with video phones, it's going to contain codecs like H.264, H.263, whatever. So it's going to send those codecs over the Cube, basically. And if you don't have this SIP pass-through SDP command, or pass-through content SDP, it's not going to allow those media capabilities to pass through the endpoint. So you would have to negotiate that on the dial peer level at that point. So if you wanted to negotiate H.264 between endpoints, it's going to allow that to do so with this pass-through content command. So you need to have that enabled if you want to pass through the SDP and negotiate media capabilities with either endpoint. So very important command there, because if you don't have it enabled, you will not be able to get video up across the Cube. It just won't work. You have to pass through that SDP. So, very important command there. Alrighty. Now, let's look at, like I mentioned here, the SIP profiles as well. But let's look at first the actual dial peers and how we're going to connect here. So if I'm going to connect, you know what, let me just draw the network too. So that way we're kind of good on how this is all laid out. So once again, HQ device. We've got HQ connecting to Cube, Site B, and these are all call manager servers, except this guy, R3, is our CME, or CUCME. And that's gonna be connected to Cube. These are all connected via SIP. Like I said, if you have a choice, use all SIP. It just makes your life easier rather than having to do this signaling inner working on the Cube. So we have all SIP trunks, basically, the HQ to Cube connection and Cube to SB here. This is a SIP trunk from the call manager perspective. On the Cube, obviously, it's just a dial peer, but we need to create a SIP trunk that communicates with this Cube itself. So I'll show you the configuration for that. If you've configured a SIP trunk before, it's nothing different. It's basically just a standard SIP trunk with all the default configuration. But we'll look at that anyway. So we've obviously got this Cube running on 10.10.1.1 for every direction. We had that enabled on the voice service VoIP command as a global configuration command. So that means that the Cube is running on 10.10.1.1, the loopback address. So all our SIP trunks then are going to point to that address, 10.10.1.1, including the dial peer over on CME. So the actual dial plan information here, we have 2.1.XXX, we have 3.2.XXX, and 4.3.XXX. So those are going to be our ranges. So if we want to communicate using 5 digits, so I would dial the 5-digit number of CME, for example, so 43002, to get the video phone on CME. and I would dial 21001 to get the video phone at HQ, and so forth. So we need to create dial peers to accommodate this dial plan. So now that we've got the kind of basic layout, let's look at the dial peer itself and how that actually works. So do show run section dial. All right, first of all, we have, let me go down a little bit. Let's say that we are communicating to Site C, or the R3 CME site. We've got a dial peer, I've named it dial peer voice 43,000 VoIP. So in this case, we're just saying 43,000. This is an arbitrary number, but try to name them something that's familiar to you. This is just the way that I named it because it makes sense to me. Name it whatever you want that makes sense to you there. We're saying destination pattern. So destination pattern is going to be the actual pattern that you're going to use to route to that destination. So if you've dialed 43,001, it's going to say, oh, that pattern matches this 43 ... and I'm going to send that out now to whatever the session target is. So the session target would be this 10.10.31.1. So that would be a place where the SIP process is running on a device out there, whether that's Communications Manager or CME. It doesn't matter. It happens to be CME in this case. Session protocol SIP v2 is going to set the actual protocol that's used. So you can do a session protocol SIP v2, session protocol Cisco for H323, which is the default. So whenever you see a SIP dial peer, you'll always see this because it's not the default. So that's good to know when you're going through it. Also, we've got this other thing here, incoming called number 43 ... And also, I failed to mention here, we have a $, which is going to signify the end of the string in regular expression form, basically. So it says, I dial 43 ... and no more. Nothing else can come after that string. If you don't put that $, you can have an overlapping dial plan, basically. If you have an overlapping dial plan, it will match both of the dial peers, and maybe that's not what you want. So I'm in the habit of using that $, to just lock it all down, make sure that is in fact the end of the string. So I'm saying 43 ... $. So 43001, that's the end of the string. Nothing else can be dialed at that point. So, but back to the incoming called number. Incoming called number 43 ... means if that number comes into the router, or the cube in this case, with this dialed number string 43 ... match this dial peer. And why would we want to even have this command in here? Well, if you think about it, if we don't have an incoming dial peer, then we're going to be matching dial peer 0, which has all the default configurations. So VAD would be turned on in that case. Voice activity detection, of course, you want to always turn that off because VAD is bad. That's all what everybody always says, so why not continue that? VAD is bad. So we want to make sure that we're matching a dial peer that's not dial peer 0, so we can actually use the settings that we want to use. So we could definitely break this out into different dial peers if we wanted to. We could say incoming called number 43 ... and put that in a different dial peer. At that point, we wouldn't need the destination pattern, but we would need codec transparent and no VAD, meaning that we're allowing these endpoints to negotiate together. And that's what codec transparent is. If a communication passes through an endpoint, through a dial peer, and it has codec transparent on it, that means it's not going to attempt to terminate that signaling session. It's going to allow the endpoints to negotiate the codec together. So it's going to pass through whatever capabilities or media negotiation has been sent through that dial peer. It's not going to attempt to negotiate it for you. So codec transparent will be there for that reason. And also, like we talked about, no VAD. So, but we could break this out. We could say session protocol SIP v2. We wouldn't need the session target command. We wouldn't need the destination pattern command. We would only need these last three: incoming called number, codec transparent, no VAD. So that would be our incoming dial peer at that point. But if you want to save time, why break it out into two? I mean, just put it in the same dial peer if you can, if it's feasible to do that. So in this case it is, because I want to use this as my incoming dial peer, and then when it goes out of the router, when it tries to find a destination to go to, it's going to use this destination pattern. So match those up accordingly, and then you don't have to use multiple dial peers for that. So next thing, so that means that that's going to allow us to go to this dial peer, or to this destination. So 10.10.31.1. So if we go look at that on the CME side, and we look at show run section voice service, and we've got our bind source interface VLAN 31. So let's check out VLAN 31. VLAN 31 is our 10.10.31.1 interface. So that's what we were talking about. If we go back to Cube here, 10.10.31.1. So we're pointing towards the interface that's bound to the SIP process here under voice service VoIP on the CME router. So we're pointing to that interface. And of course, we need a dial peer on the CME side. So if I look at that, I've got now this dial peer voice to VoIP, and I've got incoming called number, dot. So I'm allowing that then for any single number that comes in this router. Any number that comes in as a VoIP call can be or will be assigned to this dial peer. So it's just a general dial peer here. We have voice class codec command with a couple different options in it. We also have no VAD again. And also we're setting the session protocol to SIP. So any SIP call that comes in here with any number is going to be selected. This dial peer will be selected. And from there, it of course route to the phone itself. So the phone being either a skinny or a SIP endpoint. So anyway, back to Cube. So that's the dial peer to get there. So that means that any call that comes in from any number, whether that be HQ or Site B, we can go out this dial peer because the incoming called number will be 43001 from HQ or Site B, so that's the match on the incoming. And then we have a destination pattern 43001. So we're going to use the same dial peer to go out there. Now, in much the same way, we need to do that for both the HQ site and the Site B site. Now, if we want to add redundancy in there, well, I've already got that. So if we want to add redundancy in there for the HQ site, we have to add two dial peers. And you can see those right here. I've got the two dial peers selected now. Destination pattern 21001, 21 dot dot dot, 21 dot dot dot. You know, so the same destination pattern in the dial peer itself. But one of them has a preference 1, one has a preference 2. So the dial peer with the preference 1 is going to be selected first. So the lower preference wins. So it's the preferred one in this case. So preference 1 is going to select this dial peer, meaning that it's going to make the connection first with this server, 10.10.13.12. So it's going to say, I'm going to send out the SIP communication to this subscriber first. If I don't get a response, then I'm going to try to use this server, which happens to be the publisher on the HQ side. So this is dial peer logic that's of course been around forever, but been around since CME as well. So you've used this in CME probably, or H.323 gateways, depending on what you've set up. So once again, same settings here. We've got our session protocol SIP because we're communicating via SIP. We've got codec transparent, no VAD. We're good to go there. Nothing else we really need to do. So the next thing, of course, as you could imagine, is we have to do the Site B dial peer. And then it happens to be right here, this dial peer voice 32,000 VoIP. So it's just a dial peer pointing out to the other cluster. So the Site B cluster, 10.10.23.11. So great. Okay, so now we've got everything set up. We've got our voice service VoIP, our global configuration set up. We've got our dial peer set up. We've got our destination patterns and everything set up to point to the right places. Now all that's left to do is test the thing. So if I'm calling from, let's say I'm looking over my phones here, from 1001 to 32001. So first of all, let's go ahead and turn on a debug so we can see what that looks like. And I've already got one on, but that would be, let me just turn it off so you can see what the debug is I'm using. This is the best debug ever that you're going to use in the lab. It used to be debug ISTN Q931 was your best friend, but now this guy's going to be your best friend. Debug CCSIP messages. That is the best debug that you're going to come across in the CCIE collaboration lab. So, show debug. We've got the debug on now. And let me make sure I am logging, or I'm not logging to the console because there could be a lot of information. Alright, so I'll do a quick show log, check out the buffer size, and it's going to be sufficient enough, it looks like. So let me clear the log, and now we're ready to make this call. So we're going to call from 21001 to 32001. All right, so we're calling now. That's ringing, of course. Let me answer that. All right, so I left the call up there. So the call has now gone through the cube, and we are up and running, basically. So let's have a look now at the actual debug. So show log, obviously the first thing we see here, we've got an invite coming through. So we've got an invite going to 3.2001. And of course you see here 10.10.1.1, and that is the loopback address of the cube. So it was sent from HQ to the cube. So we can see the direction of that communication. So it's coming from HQ phone 1, and this is 21001 at 10.10.13.12. So it's coming from the subscriber. So that must be where the phone is registered. So we're saying that this is the source address now. So 21001, 10.10.13.12 is where it's coming from. 3.2001 at 10.10.11. Notice that this is the IP address of the cube. It doesn't know where this phone actually resides. It only knows that cube is the method by which you're going to gain access to that phone. That's the only thing it knows. Now, obviously, if I look at this communication, it's going to be hard going through to tell the direction of this communication. The way that you're going to be able to tell is using the IP addresses is going to help you out, because this from and to is not going to change. The call is always going to be from HQ phone 1 to this other phone, 3.2001 here, site B phone 1. So it's always going to be in that direction. So the way you determine what device is talking to what is via the IP address, because site B doesn't know about this IP address at all, and HQ doesn't know about site B's IP address. So basically it's going to use this cube address all the time. So anyway, so we've got the invite coming out here. We go through and we see, let me get this centered here. The content length on the invite is 0. So that means we don't have anything following the invite. We don't have an SDP here at all. So this is delayed offer. This is called delayed offer. So if you saw a content length here and you saw an SDP, then this would be an early offer call. So now we have delayed offer in this case. So that content length is 0. So that means we're going to expect media negotiation to happen once the other end picks up the phone, when we receive a 200 OK from that other end. So now we see this 100 trying come back, and to determine the direction of that, obviously we're going to use the IP address to do that. We've got, see this from, we see on cube, first of all, it sent a 100 trying, and where did it send it? It sent it to 13.12. So that's how you determine where it's actually going, what direction. So obviously you still got the phone, still got the 2 address in there. So it sent 100 trying back as a way of acknowledging that I got your invite, I'm going to try and look into it. So next thing it's going to do is send the invite out to the far end. So it says, all right, now it's time for me to do my job as the cube and send out the call to the far end. So in this case, it's going to say 3.2001, and it's going to be 10.10.23.11, and it got that from the session target of the dial peer. So that's how it knows where to forward that. Those dial peers have dictated where this call gets forwarded. 10.10.23.11. So we've got now the from here has changed. You see, it's still from 2.1001, but it actually has this 10.10.11 address, which is the loopback address of the cube in this case. So it's using that to basically hide the address of the HQ side. So it only knows about the cube address. So we know now that if we ever see 2.1001 at 10.10.11, that means that the cube is talking to site B, because site B doesn't know about any other address. So the cube now, 3.2001 at 10.10.23.11, so we know that that's sending to site B. So it's talking to site B directly. All right, so once again, invite goes out. We see that there is a content length of 0, so there's no early offer in that invite at all. You can actually have cube generate an early offer for you if you want, like with the early offer forced command. We didn't do that in this case, so that's the content length 0. And now we receive 100 trying from the far end, meaning, let's see, from 10.10.23.11. So we know that that's coming from site B at this point. All right, so now we received a 180 ringing. So it was trying. Now it found that endpoint, and it's actually ringing that endpoint. So we get the message on that. So we receive the invite from site B that it is ringing at that point, and now we're going to send that invite, so sent, a 180 ringing, out to the HQ device, 10.10.13.12. So it's doing its job perfectly now. It's taking the invite, or the 180 ringing that it got from site B, and it's going to send that out to HQ. So now, at this point, we know that, like, the phone is actually ringing. We're getting ring back on the phone that dialed the number, and we're getting ringing on the phone that we called. So now the next step it would be for the phone to actually pick up the call. And that's where we receive this 200 OK. Receive a 200 OK from 10.10.23.11. So that's coming from the site B cluster towards Cube again. So we receive that on Cube. And now we see this content length 233, which means that there's actually something attached to this 200 OK. So if we look at it, we see the media capability negotiation. So we see that these media capabilities are being discussed. So if you look at this carefully, we see that this is a SIP call. The connection IP, this 10.10.21.252, is actually going to be the IP address of the endpoint. So that's going to be where the media is going to flow at some point. We have bandwidth modifiers for 8008, meaning G729 in this case. But you can really tell this M equals audio here, this 32312, that's actually going to refer to the port number. And this RTP AVP 18, that doesn't make a whole lot of sense. What is that? So this is actually, if you go down to the next line, A equals RTP map of 18, which is G729. So it's basically saying that I have G729 to offer you in this 200 OK. And there's no other codecs there. So I'm saying G729 is basically it. So you have to accept that, or we're going to have a problem. So anyway, so we move on here, and we see that this 200 OK is now sent to the HQ cluster, that 21001, and we've basically forwarded that request, or that media negotiation here, the media capabilities. G729, we forwarded that right along. And now, to complete the communication, we receive an ACK from the HQ cluster, 10.10.13.12, and we're going to say, you know what, G729 is completely cool with me. I'm okay with that being the codec that we use. And then now, Cube is going to send that ACK along to the Site B cluster, and there's the codec that it actually sends along to Site B, and that's it. You can see that's the end of the log, because that's the entire communication that happens between those two endpoints at that point. So, media negotiations, obviously, the one thing we didn't see here is video. So let's actually take a look at a video call and see how that differs from an audio call in the SDP negotiation. So let me clear this log first of all, or let me end the call, and then I'll clear the log. All right, clear the logging buffer. Now I'm going to call Site C for 3002, and that's going to allow me to share some video here. So for 3002. All right, so I've got video going now between those two phones, between HQ phone 1, Site C phone 2. So let's have a look at that. And we'll go through this a little bit quicker just to get to the SDP. So get invite coming in to Cube, of course, from HQ. We're sending an invite out to Site C. So Cube is now regenerating that invite. We're sending a 100 trying back to HQ, because that's what needs to happen. It needs to let HQ know that it is trying it. We've received the 100 trying now from Site C, from the R3 device. And now we received 180 ringing from the R3 device. We forward the 180 ringing onto the HQ cluster. And now we receive a 200 OK from the R3 device with a content length of 366. So that means there's an SDP here. So we look at that, and now we see that there is audio or video information there as well. We had this M equals audio line before on this port number, and now we see that we can actually use video with this M equals video line, and that's using port 17080. This other thing here is the payload type, 97. This is a dynamic payload type between 97 and 126. it can be, but 97 is chosen here at random, but it's usually 97 is what it ends up as. I've only seen 97 and 126 be used. Anyway, so 97 being the payload type here, and the connection information, so 10.10.131.2, so that's going to be the IP address of the phone there. The RTP map now, so 97 we see, RTP AVP, 97 is actually referring to H.264. So H.264 in this case is the video codec. So once again, this is the 200 OK received from R3 to Cube. Now what we've got to do is forward that back out to the HQ device. And that says the same thing. We've got the RTP map 97, we're sending H.264, we're only offering that codec. And then now the HQ side is going to say, ACK, I completely accept that codec. I'm cool with that. H.264, we're good. And then we get an ACK back, sent out to the R3 device, and that's it. We've got our video call up now because of this. Now remember, there's a couple things that we did to get that video call going. And if we do show run section voice service, pass through content SDP. Definitely need to have that command on there to allow it to pass through Cube. So that's how the video call will get up between those two devices at that point. Any questions so far? Doing okay? Okay. So with that, there's really not a whole lot more to talk about. It's basically that's the basic setup of Cube. Allows you to get the video calls going, allows you to get the audio calls going. We basically just used dial peers. We've used H323 or SIP trunks. In this case, we just use SIP. One more thing I do want to show you too that I didn't show you yet is the actual configuration of the SIP trunk. And this will be the same on both clusters, both HQ and Site B, that is. And there's really nothing to it. I mean, if you've configured a SIP trunk before, it's just like any other SIP trunk. Go Device, Trunk, and I've already got it created. This happens to be the Cube SIP trunk. I can't stress enough how much you should put this in a specific device pool. You can control codec negotiation so much better if you have the trunk assigned to a specific device pool, because your region is assigned to the device pool. And this is something that you'll see as a recurring theme, throughout trunking configurations, is that you need to have a separate device pool for that trunk. You can control, which servers are going to be connecting to which devices. You can control the codec negotiation, which is probably the most important for the CCIE Collaboration Lab. If you are asked to have a specific codec across the Cube trunk, then you need to be able to have that in a specific device pool. So, definitely important to have a specific device pool here. Other than that, everything else is straight up. We have this calling search space. Like I said, recommend calling search spaces and partitions all the time. It's not a gimme where you can just use the none partition anywhere, really. Just get in the habit of using partitions and calling search spaces. It's going to help you out in the long run. The gateway trunk calling search space here just has access to the internal phones, and I have all for significant digits. So of course you saw that we're using 5-digit dialing between these two sites. So that is just like any other gateway. We're going to accept the digits coming in, and we're going to forward them on to whatever the partition is in this device that it has access to. So that's for inbound calls, of course. And as we keep scrolling through, we've got our destination of 10.10.11, which was the loopback address of Cube. And we also did the SIP trunk security profile, non-secure SIP trunk profile, and standard SIP profile. And like I said, that is it. There's nothing else to it. I mean, maybe you were expecting, oh, we have to put in something clever here in the SIP trunk security profile, or maybe we have to figure out something for the SIP profile. We don't really have to at all. There's other options you can add, of course, but for your basic setup for Cube, there's really no need to do that. So this is the actual trunk configuration here on Communications Manager on both sides, whether it be HQ or SB. So any questions there? All right. All right, we're looking good. So guys, I really appreciate you coming to the lecture today. Obviously, if there are any questions, reach out to me, avasser@ipexpert.com. I'd love to help. So if you have any questions or anything that you can think of outside of the lecture, please let me know. Otherwise, I really appreciate you coming today, and I will see you guys next week. Thanks.